Today we will discuss how to use R markdown for reporting the analysis, results and codes. First we will open a R markdown file. We are going to files. First make sure that you are in the folder where you want to store your files. Click on these three small dots and go to your desired folders. How you want to work. This folder. Okay, so my folder is here. I want to use this folder as a working directory. So I'm clicking on this gear icon and click on the set as working directory. Here I will open an R markdown file where I will store my codes and the results. So I'm giving it name lesson 3. I'm changing its title so that the web page also has this name, lesson 3 R markdown and basic functions. I'm adding author. So this is unknown part, so I'm putting inside a quotation mark. So here we can find two. I don't need this, I'm minimizing. There are two modes. One is source, another is visual. Source means everything you need to write using codes, but in visual you will have more options to format your document. Here you can just click bold, italic and other formatting options, so you don't need to type any codes. So first we want to make a title here. Here you can see that there are different options to format the codes. Here you can insert different figures, tables or equation. You can use this function also to insert a table. If you click here, you will see how many rows and how many columns you need. So we don't need it now. Here this icon is very much important because in different languages you can code here. R, Python and some other languages we will use R. When we need to input any codes, we'll click on this icon, and here, yes, here we are inserting a header. So there are different levels of header. This is the biggest or highest level header 1 and the lowest. So if we click here we see that it automatically changes to heading. So here we are writing reading dataset. Okay. So before reading a dataset from a folder, we need to make sure the dataset is in the working directory. We can set working directory using different methods. Number one, we can use this auto numbering feature here using session set working directory choose directory, we can browse the desired location here, and then we can just click open. You may not see any files here, but don't worry, all the files will remain inside the folder. So we can set working directory from session, set working directory, set working directory. There are several options. If we want to set the working directory to the folders containing this lesson 3 script RMD file, we can just click set working directory to source file location. If we click here, we will see a message in the console that our course means PhD inside this folder our working directory has been set. If we want to change this directory to another folder, we can go again, choose directory, and we can go to another folder. For example, Python project I am setting here. Just open, you will see that the folder has changed to Python directory. Here also the working directory has changed. But we need to go back to the PhD folder. So we can browse again from Google Drive and R and PhD. Okay, open. So we are going to our previous working directory. Set working directory, then select different options. Second is typing command. Typing command. If we give command, like if we write this code here, so we need to write code, our code. Don't worry about this and do not delete this. And this will tell our markdown that the following command is from our software, our language. So if we run this command, it will also set our working directory to this folder. Here are the messages that working directory had changed. Oh, sorry, this is in Python project, but we need to change this to the R course MS PhD. So we are running it again. So working directory has changed again to our PhD MS PhD folder. Number 3, typing a command. Number 3, we can change from this small dot from the Files tab of the environment pane. Files tab in the environment pane. Environment pane. So we can use this as well. So using these 3 methods, we can change our working directory. Once we have changed our working directory, we can read the data set. We want to read these data sets, XLSX. We can view using the original software, as this file has extension XLSX. This is a typical Excel data file. So from this data set, we will read this data set, and its range started from B7. If we click in another cell, this reference will change. So its starting cell is B7 and its ending cell is here. If we click here, you will see that N507. So if we select all these, so this is the data set we want to read. So its range is B7 to N507. So we are minimizing this. Before that, we need three information. One is data sets. This is the file name. This is the sheet name, wrangling, and this is the data range that we want to read. So these three information we will need to read this specific portion of the file. So data sets, wrangling, and the data range. Okay, we are going back to our R program. We are giving a data set name. Data set name is, for example, data. So this data will come from the data set. We need a library because our basic commands do not have the option to read Excel file. So there is a package called read Excel, and from this package we are using the command read underscore Excel. Then we will give the dataset name. Dataset name is datasets .xlsx. Then we need the sheet name. Sheet name is wrangling. And then we need the data range. Data range is B7N507. B7 to N507. So inside the inverted comma. So this is not a command. You see, this is normal text. We need to put this into the command to run this. We are cutting this and we are inserting our command here. If we run this code, this data set will be read by this function and will store into this object data. So we are running this. It says path does not exist. It means that our working directory is not right. If we say click go to working directory, it shows that Python project is our working directory. But actually this data set XLSX, this is inside another folder. So we are changing the working directory, or simply we can just click set working directory to source file location. So now this has changed to our course MS PhD. Now we are going to the working directory. It says data sets XLSX. If we run this again, it says that path does not exist. Still it's not able to find our desired data set, but our working directory is right and we see that the data set is here. So what's the problem? The problem is in the spelling. You see, we have typed here dataset XLSX, but here it says data sets. Okay, we are including one S here, then run this code again. It says that dataset has read perfectly. So still you may see some error because this spelling may be different from the dataset spelling here. As a coder, you need to write the spelling accurately. So D is capital, S is capital. So this is the right code for reading this data set. So working directory and the spellings are very much important. If we want to see whether this data set has read perfectly, we can check its first 6 lines by giving command head. Now we are running this command again. It will show the first 6 lines. We see that first the heading serial number January, February, that means up to December perfectly. But what about the tails? The last 6 lines, if we want to read the last 6 lines, we will give again this R code and type here tail data. It will show you the last 6 lines. So up to 500. If we go back to our data sets, we see that here number 1 and the last contains 500. So this data set contains 500 rows and 13 columns. 13 column means 12 months and the serial number. So 13 columns. Now we will check this data set. So we are again give another R code command. You can use shortcut to insert R command. Shortcut is Control plus Shift plus I. So Control Shift I. It says image, but we are not. Control Alter I. Oh, sorry, Control Alter I. So it's not Control Shift I, Control Alter I. So R command, we want to see its structure of this data set, str data. So it will show more detail. We see that this is a data set or data frame in table format. It has 500 rows and 13 columns, and these are the variables. Each column is considered as a variable. Serial number January to December, and this is the data types, numeric data, and this is the lowest and highest value here. Lowest means first row and highest means the last row, and these are the first few values are shown to understand the data types. If we see its summary function, Control Alter I, summary data, it will give you some summary statistics. January, its lowest is 0, highest is 1. So these data set contains only 0, 1 value. If we go back to our data set, you see these are 0, 1, 0, 1. Actually it shows the scarcity of money. If the respondent says that I have money shortage in 1 month, we will put 1. If they don't have any money shortage, we will put 0. So 1 means yes and 0 means no. It indicates the money shortage reported by 500 respondents. We need to calculate the column frequency to graphically compare different months. Which months have the higher scarcity of money shortage? And we will categorize the respondents based on their total yearly frequency. That means first respondent has frequency 1, 2, 2. So first respondent has 2 months of money shortage. Second respondent has 1, 2, 3. Maybe other respondents have money shortages in other months. We're going back to our R markdown file. So the 0101 value, but we do not need this serial number here. We want to remove this serial number from the data set. We want to show summary for only the months. So how we can subset this data set excluding the serial number? So now we will subset the data set by excluding the SR variable. SR variable means the first variable. So we have easy method of data slicing. For example, if we change the data to data 1, that means this is subset we will use, and the subset will be stored in this data set. This is our original data, and these square brackets are used to subset the data set. Here we will use comma to specify the rows and columns to keep or to exclude. If we keep blank here, it means all the rows will be selected. Before the comma, the row indication, and after the comma, column indication. We want to exclude the first column, means -1, but we want to keep all the rows. If we see this data head data 1, because we have changed the data set name here, data 1, we will see now there is no serial number column because that column has been excluded. So we can now add all this value to see how many ones are in the January month, how many ones in the February month, and how many are in other months. So calculate the column frequencies or summation. Here frequency, I am telling that because if we add all this number, actually the 1 will be added. So the summation will indicate the number of ones. So we will use the row sum row sums function to do this. So row sums, if you use row sums data 1, we will see that $500 values. Actually, it has done the summation over the rows. If we go back to data set, it has actually done, it has added all these numbers and put a summation value here. But we need to sum over this column. So we need to change this function to call sums, not row sums. This is call sums. Call sums. Now we see that our result has changed. January 143, summation of February is 177, March 196. So these are the sum value. We need to store these values to a new object to use this for visualization. So we are creating an object to store the value of these summations. So we are creating this sums object to store this call sums data1, but we need to convert this to a data frame to further explore this. So to do that, we need to put a command as data frame, so that this call sums create a data set. Now we'll see the structure of this data set. Sums is our data set, so we are giving this command. It says that this data frame has 12 observations and one variable, and the variable name is call sums. But we want two columns. First column will indicate this month name, and the second column will indicate the value. So further, if we see that the row names of this data set, row names of this data set sums, we see that row names are January, February, this type of things. So we need to convert these row names to column names. If you type here sums to see how does it look like, you see that this sums data set has one column names call sums data1, and these values are here, and this is the row. But we need to convert this row titles as a column, as a variable. So, and we need to rename these call sums to frequency or values. We need one library to do this. The library name is tidyverse library. We should have loaded it before. Anyway, we can also load here. So we are loading this library tidyverse. If you don't have this library, you cannot use this. To install the library, you can go to packages here and install the library, or you can also install from tools, install packages, and here you can type tidyverse and click install. Keep this tick mark unchanged, because this package may depend on other packages, so that during installation of this package the other dependencies can also be installed. So from here also, if you click, it will give same thing. You can also install using command install packages. Just you need to put the package name here, tidyverse. You can also specify the dependencies true, so that this can install using this. I am not typing this command here because you need to install this package only once. If you uninstall the whole R program and R Studio, then you will need to install this again. So we don't want to put here this command, otherwise when you will run this script, this will install the package again. So in my case, I have already installed, so I don't need this tidyverse. We want to bring this to a column, and we are giving another name here, sums1, and we will use this sums data set, Control Shift M. This Control Shift M, I need to insert here some rows. Here we will introduce piping operator. Piping operator percent greater percent, and its shortcut is Control plus Shift plus M. So when you click on Control Shift M, it will give you this mark. It means that, what does it mean? It uses the previous output as an input for the next calculation. So this data set will be used as input for the commands we will type here. So here what we are doing is row names to column. Row names to column. It should come automatically if we run only this part. If we run only this part, Control Enter. So this library has loaded. So if we type the partial command, it will show you some hints, because we cannot memorize all the commands, so it will help you. Row names to column. So what will you give the name for this column? We are giving months. We are giving here months. And see the sums data set, sums 1. How does it look like? Okay. Now we see that the first column has a name, months, and the second column contains value. So we want to rename this as frequency. So sums 1 frequency equal sums 1 call sums data 1. So it will create a new variable. This will create a new variable, and using the same value of this call sums. Now if you run this again, you will see one additional column called frequency. So it has not overwritten this column. But if we want to just change the column name, we are putting this in comment out, because to create a new column, $sign is used. But if we want to rename the column, we need to use a rename function. We can also do this like sums 1. So it has the column names. This is the name. We want to change this as sums 1 So if we see this data set, it has created one column named months, and it contains some month names, and another is column. So we need to change this column name. First we need to see the full name of this column. If you type here names sums1, it will give you the column names, calls sums data1. So in R we do not usually use these brackets and other special characters. So we need to change this column name to frequency. So here we can again use another pipe operator, Control Shift M, and we can use this rename function. Rename, the old name is this, we can copy this. This is old name and this is new name. New name is frequency. If we run this and see this sum1 data set, let's see first what happens. It says that unexpected equal here, because this type of name is not usual in R. So unusual column name, if we want to use, we need to put tick marks. Tick marks means the keyboard key left to the 1. If we select this and click here, it will put 2 tick marks. One is here, another is here. If we run this again, can't rename the column that don't exist. Okay. So sums equal so we need to rename if we see this column name, we want to change this column name to frequency. Okay, we are using this sum2, it will use sum1 as input and rename its call sums data to frequency. There is an error. If we see the output, we see that we have two columns. One is months, another is call sums. If we run this sums1, we see that the second column name is some sort of unusual names. So this is difficult to manage in R, so we will give a simple name here called sums frequency. We will use this sums1 as data set, sums1 as input, Ctrl+Shift+M, and rename this, and we'll give a new name frequency to this call sums data set, call sums data1, call sums data1. As this is an unusual name, we need to put this inside a tick mark, otherwise it will show error. Let's see first the error. If we see the sums1 again, hit this play button, it says that can't rename column that don't exist. If we change this, if we put this column inside a tick mark in the key remains the previous key of 1 in the keyboard. If we hit, it will do 2 tick marks around this variable name. We hit this play button again. What happens? So we see that it has renamed actually, and now we need to put this in another object name sums2. Sums2, we will view this sums2. Run this code again. You see that previously it was months, call sums, and now it has become months and frequency. Now we will visualize this months and frequency here. We are putting another command, and we will now use ggplot function. ggplot. This ggplot function comes from ggplot library, which is also a part of tidyverse library. So without this library or ggplot library, the ggplot command will not work. So ggplot function, inside this first we need to put the data set. So this sums2 is our data set. So here we putting sums2. Sums2 is our data set. This is ggplot, means grammar of graphics. So it will take different layers as command. So it will create actually, if we click here, it will create one blank canvas. So in this canvas we will add different layers to visualize our data. So we are giving one plus sign, and we are giving some aesthetics. That means what will be drawn along the x-axis and the y-axis. So our aesthetic is x equal months and y equal frequency. So frequency. So these are the aesthetics function, and inside there are two elements. One is months, another is frequency. So still we will not see anything here, because it will just say that axis names, but it will not put any geometric structure here, because we have not specified any geometric shapes. So we are giving another plus, and right here geom call, so that we will draw a column graph or bar graph. Now you will see the graph is here. This graph, if we want to change the color and feel of these bars, we need to work here. If we change feel, it means the inside fill color, and only color means the border. First we see the color is blue. Color is blue. You see only border will change, but the fill will not change. We need to change the fill blue, it says that blue and blue, but it shows actually red. So because we are giving this red and this blue inside the aesthetic, so if you put values inside the aesthetics, it will not work, because aesthetic always demands the variable names, not your name. But if you put these two values inside here, that means without the aesthetic function, it will give you the blue. But we don't want these blue bars everywhere. We want to give different colors and fields for different months. So what should we do? So we're deleting this, and we are giving here some commands that its color should follow months. Also, the field should follow months. If we hit now, it will give you the 12 months in different colors. But still you see that the month name is not in order that you want, because January is here, February somewhere here, so it's not in good sequence. If you change the sequence of this month name, you need to change the order in the data set. So before giving this ggplot, change order of the x-axis items. Our data set was sums2, and the order we want to change the months, because this will be as factor, because these are not numeric, these are factors, and we will change the labels. So factor, the data sets sums to these months. So we want to change the labels of these months. So here we will use two things. One is labels, the order we want. As we use multiple elements, we are putting here C, then Jan, Feb, Mar, 3 letter, because here the name is this, but we want this sequence, not this sequence. March, April, May, June, July, August, September, October, November, and December. As this is a string, we need to put inverted comma, just select and hit the quotation mark. If you run this code again, you will see that January, February, March, April, these have changed the sequence that we want. Still we are not happy, because this January is a proper noun, so we need to write J in capital letter, F in capital letter, M in capital letter. So we have changed the labels, but we also need to change the labels. So labels, labels. So here we will type again these 12-month names, copy, paste. Now just you need to type the spelling that you want to see in the graph. M A M J J A S O N and D. So you can press enter here to see good formatting. Okay, if you run here, just look at this, label will change. Now the label had changed, but we want to change this theme of this figure. If you want to change the figure theme, you can use theme test, so removing all the backgrounds, or you can use theme BW, or you can use theme classic. It will change the background and other styles. Theme classic, run again, this theme again. So I am keeping the theme B and W here, for example. Now we need to change the x-axis and y-axis level. So this is called laps. We can create title here, title equal inverted comma months of money shortage, and the x-axis title, we will not give any title here, so we are leaving as blank, just quotation mark, because we don't need to put this months here. Everybody knows that January to December, these are the month names. So as a y title, we are giving its frequency or number of respondents. If we run this, you'll see that the title had changed, months of money shortage, number of respondents. Now we want to bring this legend to the down. Okay, so again we need to change the parameters inside the theme function, legend position. Here you can change many things from here, a lot of options you can change inside the theme. Legend position, if you put here none, it will remove the legend. If you put here bottom, it will place the legend in the bottom. So top means it will bring to the top, but we don't need this legend, we are just leaving it. Now if you want to save this plot, save this figure to your working directory, if you go to file and go to working directory, here if you want to save this figure in high resolution, use ggsave command and give a file name, for example myplot.png. this is the extension. You can use jpg, TIF or PDF or other options. Here DPI means dot per inch. We are putting 600 as resolution. It's a good resolution. Do not put less than 300. And do not put too much resolution because it will consume more memory. Now we want to specify the heights of this figure. Height is 4 inch and width is 8 inch, and the units are in inch, so IN. If you run this command, we will see one my plot has been created here. Still it's running, so we will wait. So it has done. So if we see this my plot here, so it has created this figure here, nice figure, short of money shortage. Run this code. So you don't need to run this code several times because it's already saved. So why this figure is not coming? We're closing this. Sounds good. Here is the problem. If you run this command several times, it will override the month's names. Previously it was January to December. You have already changed to the capital letter. If you change again, it will show a recursive error. So bring this code to the previous chunk so that this does not conflict with the figure items. So run this once and run this again. It will give you the figure in a nice format. If you want to calculate, because our task was to compare the months, if we see the months here, March has the highest shortage. So February, March and April, these 3 months, the shortest period. The December, this time the respondents didn't have any money shortage. But we want to categorize the respondents based on their total values. That means number 1 respondent, how many ones, number 2 respondents, so the 500 respondents, we will categorize them based on their number of months of money shortage. So here we will categorize the respondents based on their number of months having money shortage. Now we need to calculate the row sums. Go back to the data points. Here data 1, that shows January to December data set. So this data 1, we will use this data 1 to calculate the row sums. So row sums, data 1, row sums data 1, and we are giving here name of this object as shortage, and here we will see the head of shortage, because it will give you 500 row totals. So it's a big, we don't want to see the full. We will see only the head of this. So we want to convert this to a data frame. So here we are putting as data frame, and now we see that a row sums, we can rename this shortage, Control Shift M, rename, so we do not see the full title here. So first see full title, we see structure function, and if we run this, it says that the variable name is row sums data 1. Rename to what? Rename to frequency or something. Frequency. We are giving this frequency, small letter frequency. The previous name was this, and this is an unusual name, that's why we are putting inside the tick mark. So we are giving here one name, short. So we are changing this object to short. Now we will see the short object structure. Now we see that the variable has changed to frequency. Still, this is frequency. So data set name is short. Let's see its head, short. You see that it's a one variable named frequency. So we will see that the first respondent has 2 months of money shortage, second has 3 months, 4 months, this type of months. If we see the summary, some descriptives of this frequency column or frequency variable. So summary short, you see that the frequency, the lowest frequency is 0. That means there are many people who don't have any money shortage. The highest, out of 12 months, 9 months those people have money shortage. So we want to see the frequency in each of these categories. If we want to see the frequency, we need categorical variable. Categorical variable means factor variable. For continuous data, the summary contains minimum, maximum, quartile value, median value, mean value. But for categorical, it will give you the frequency. So we can convert the numeric variable to factor variable with Ctrl-Alt-I. So this short has a variable named frequency. So if you type here $, it will show all the variables. So we need this frequency and we need to convert this as factor. Short frequency. So this short frequency will convert to factor variable. If you now see the summary of this short data set, you will see that it gives the frequency. That means there were 141 respondents who have money shortage for 2 months, 113 for 3 months, 110 for 1 month, and 69 for 4 months, 34 there are no money shortage, 21 and others. So we need to categorize this frequency based on their values. We can also plot this in graph, but before that we will categorize this. Categorize the respondents based on their number of months with money shortage. How? Low means money shortage who have less than 3 months of money shortage. Money shortage medium 4 months, or 5 months, 4 to 5 months, 4 to 5 months versus 6 months of money shortage. High, more than 5 months of money shortage. Money shortage. We'll categorize this, but for categorization we need continuous variable. For categorization we need numeric or continuous variable, discrete or continuous or discrete variables. So we can convert this short frequency as numeric variable, short frequency. So we are converting again to numeric variable. Now we will categorize these frequencies into different categories. So we will use cut function to cut the values into different categories. So cut what? Cut the frequency, and here we need to put the values of breaks. So the breaks will identify how many categories we need and what are their range. So if we put a infinity minus infinity to we want less than 3, so this is one category. Another is 4 to 5, so this is 5. Another is more than 5, means up to the last value. So INF, IN is infinity. That means we don't know the highest value. We are putting the highest infinity and the lowest infinity. So this is one category, infinity to 3, and 3 to 5 another category, and 5 to infinity another category. That means we need up to, or we need less than 3, infinity to less than 3 is low, and 4 and 5 to medium, and greater than 5 to infinity is high. So we are here, we need to put level. So levels we are putting here, we are bringing this down. First category we will see, we are putting C to combine multiple elements. So first is low, we don't, R doesn't know this value, so we are putting inside the quotation marks, and third is high. So one thing here very much important, to write closed cut function right is true. If you want to see the help, what does it mean, this right, here see the cut function, you can see help for another functions as well. You see the right true, what does it mean, right true? Its explanation is right is a logical value, that means it may be true or false, indicated if the intervals should be closed on the right. So right closed means right true means right value is closed. Still confusing. It means that right value is included in the category. That means when we put is 3 here, it will calculate the first category up to 3, but we need actually less than 3. So we cannot put here 3, we need to put here 2. So it will take 2 in this category. So second is 2 to 5, that means 2 will be excluded because 2 is not closed here. left is open. That means 2 will not be included in the second category. Second category will take 3 to 5, but we need 4 to 5. 4 to 5 means, so here you see that the category is not exhaustive category. For categorization, we need to maintain two principles. One is mutually exclusive, another is completely exhaustive. Completely exhaustive. Mutually exclusive means this low category value will not be overlapped with medium category value. Completely exhaustive means all the respondents will fall in only one category, but all the respondents will be categorized. Nobody will left uncategorized. Here you see that less than 3, that means 3, the respondents having the value 3 will not go anywhere, because less than 3 is low, 4 to 5 is medium, but where will this 3 go? So we need a category that will take the respondents having 3 value. So we can tell that low means up to 3. Up to 3, medium means 4 to 5, and high means greater than 5. So in this way, this will be completely exhaustive. If we type here medium 3 to 5, low is up to 3 months, medium is 3 to 5 months. That means the 3 will go to 2 categories. So this is not mutually exclusive. So here we are typing 4 to 5. So now this is very much clear. So now we will rewrite our code to match with these categorization principles. So first we will take up to 3, that means we will type here 3, because right is closed, that means this 3 will be included in the first category. Second we will take greater than 3, that means 4 up to 5. The last will take more than 5, that means 5 to infinity means this file will remain open, that means it will be included in the previous category. Now if we run this code, it will give the full data set. It means the 500 rows, low, medium, high, this type of thing. But we need a summary function. We need a summary function to summarize this. We can put in a variable named category, and if we see the category table function, category table, so it will give you a frequency table. Now you see that low is 285, medium 182, and 3 is 33. This is high. If you want to sum all the category values, how many values is here? 285 plus 182 plus 33. So it gives 500. So all the farmers, all the respondents have been classified properly. Now, if you want to see the percentage, calculate the percentage. So table category. You can check the length of this category, category of short frequency, category of short, you will see length of short frequency. So category of long length of the frequency is 500, that means there were 500 rows. So we'll multiply this with 100 divide by 500. Now we will see a frequency table in percentage. So 57%, 36%, 6.6%. You can also show this in figure, or you can use this in other types of analysis and reports. We see that in the medium category there are 36%, but in the low category there are higher number of respondents were in the low category. High category was the lowest. Okay, that's the use of R markdown for reporting. You can see this as HTML. If you need this in HTML document, you can also export this as PDF. You can also export this as Word document. That's the beauty of this R markdown. We are saving this and we are knitting this as HTML. It's processing now, and in the viewer we can see this. How does it look like? So you see that it has been nicely formatted a web page. So all the commands are in the shaded box, and below which the outputs, and you see that the full commands and outputs are here. So okay, now we can publish this. So thank you very much.